Hey there, developers. This is part of a series on the solid principles. Today we're going to be going through the second of them, the open-close principle. Bertrand Mayer brought up the open-close principle back in 1988 when he was discussing object-oriented construction. Essentially, he stated that a module should be classed as open if it's still available for extension or modification, but classed as closed if it's being used or available by another module. So, if a module or piece of code is being used by somebody and it's in production, you should really leave it as it is. So in essence, he's stating that the module, if being used by somebody else, shouldn't be modified to extend its capabilities or its signature, such as data structures or functions within it. So if it needs to be used by someone else, it should be inherited into a new class, and then that new class should then be modified. There's nothing worse than coming along to an existing class that you've been working on for ages to find the signatures changed and now your code is broken. It's better to inherit that class into something else and then work on that. There's some interesting ways of constructing your code to make this much easier going forward so that you don't encounter these problems when you go into production. So here is an example that I put together of a system which would be hard to manage going forward if we released it into production. We have a discount scheme which will calculate the discount on a cost, and we have various different schemes which we want to be able to put into production. And currently we only have 2 or 3 schemes which will calculate 1, 2 or 3% based on what type of scheme you're using, and we'll define it down here and then run it to calculate the discount. And we're going to then pass in a value which will then give us the discount back, depending on which discount type we've chosen. But let's imagine we put this into production and then we come along and we want to add another scheme. We then have to go back and modify this existing piece of code to add another case statement into it to handle another scheme. But that makes the code quite brittle. We then have to retest that existing code, and somebody's already using it. They don't want to have to change their discount type just because we've added a new one. So there are better ways of restructuring your code to be able to handle that. And that gives us the open-closed approach, that the code that we released previously is closed, but we're still open to extend it through different methods. So what are those methods? How can we do this code in a slightly different way that it is more manageable? So what I'm going to do is I'm going to wipe out what we've got currently, and I'm going to redo this again, but in a way which should be much more easy to add new discount schemes. So let's just say we have a discount scheme which is standard. So let's put in a discount scheme standard, and we're going to put in a function which will calculate the discount for us. And by default, the standard scheme will take the cost, multiply it by 1%, and give us the result back. And that's a perfectly valid piece of code, and we can define down here at the bottom that we want to run that piece of code. So we can say discount scheme standard, we'll call that scheme. This is a new discount scheme standard, and we want to get the result back from that. So we'll say the result is equal to scheme dot calculate discount, and we're going to pass in the cost, and that will give us back our result based on calculating discount on that amount. Now already the code is a lot simpler. We only have one function within this class, and we have a much simpler way of calling it without having to do a lot of setup and telling it what type of scheme it is. It already knows what type of scheme it is by the fact we've defined it here. But okay, let's just say we wanted to add another scheme. later on, and then maybe do 50 schemes, all different types with different types of code inside them. Instead of doing if statements inside one class, which we have to come back and modify each time, what we can do is just extend the existing class to do something slightly differently. Now, to do that, we kind of have to expose this class in a certain way. So I'm going to make this a virtual method. And I'm going to create another class called discount scheme awesome. And that scheme will implement the same sort of signature as the original class, but it's going to do it in a slightly different way. So we're going to inherit the original standard scheme, and we're going to override this function. We're going to say to it, okay, we don't want to use that one. We want to use our new one. Just going to do this in shorthand. And the awesome scheme will give us 2%. And you're thinking, okay, that's great. We've now got two pieces of code that look virtually identical. You've extended the original one, so now we've got a similar signature, but it does something slightly differently. How does this help us down here? Well, because these are inherited, we can now say this is now a discount scheme awesome, and the result will be a different value because it will now call the method in this function. So let's say we've got another one. So we've got discount scheme super, which is now going to give us 3%. And now I can say discount scheme super, which will give us 3%. So I don't have to change this original code and put changes to the if statement anymore. I can just inherit the code down here, and then I can replace the bit of code that I was using with the new one, and then I don't have to worry about retesting my original standard class, which is already in use by another system. It's never going to get modified. We're just going to replace that signature with something else. And this is kind of the heart of the open-close methods. We want to design things that are open for extension, but closed for modification when it's being used by somebody else. So I hope that helps understand the second principle of Solid, the open-close principle. This is a really super simple example. You'll probably find much more complex examples out there on the net, but I hope this has been some clarification of how it works for you. Thanks a lot. Make sure you hit that subscribe button and switch on the bell icon to get all notifications, and we'll see you in another video.